we've graphed and we've written equations, so we've had to do a little bit of solving work, but now we're going to focus strictly on solving exponential equations and inequalities when they have the same base. So all we're looking at right now is equations where they either already look like number one here, where the bases match, or where I can make them match. All right, and we're going to rely on our exponent rules. Those are going to be essential to get through this. And our property of equality, which if you pause and think about it for a minute, is kind of intuitive. So if I've got b to the x and equals b to the y, because these are the same, then I know that this statement is true, right, where x equals y. And that's what we're going to rely on here. So I have just one exponential thing. There's one base raised to some power. That power is an expression, but it doesn't matter. And one base raised to some power. So the first thing we do is check to see, are the bases the same? 3 and 3. They match. So I can effectively ignore them and just solve the resulting leftover equation. 2x minus 1 equals x plus 2. So we solve x minus 1 equals 2 plus 1. So according to this, x equals 3. We want to go back in and double check to make sure that what we've done is going to work. So I'm going to take 3 raised to the 2 times 3 minus 1. Is that the same as 3 raised to the 3 plus 2? Well, that's 3 to the 5th. Is that the same thing? 2 times 3 is 6, minus 1 is 5. It works. I know that x equals 3. Okay. When we can make those bases match, these are really typically going to be just Algebra 1 level work. All right. So let's move over and look at number 2. I've got single exponential expressions, but my bases don't match. Well, so I want to try to see if there's a way I can change this one so that it's a 2. So we're going to think about, can I make 4 out of powers of 2? Because I want to rewrite this as 2 to some power squared. That gives me 4. And then we're going to keep the x minus 1 as an exponent equals 2 to the x plus 5. Well, I've rewritten it. Now it's exactly the same kind of problem that we started with before. I can ignore my bases now that they match, and I'm going to solve 2 times x minus 1 equal to x plus 5. So 2x minus 2, x plus 5, move the x minus 2 equals 5 plus 2, so x equals 7. Again, before we walk away from it, we want to check and make sure. Is 4 to the 7 minus 1 the same as 2 to the 7 plus 5? Well, that's 2 to the 12th and 4 to the 6th. Are those still the same? Well, if I think back to, we changed 4 to 2 squared. So if it's 2 to the 2 times 6, I get 2 to the 12th and 2 to the 12th. If you don't want to mess with that, then you're going to grab your calculator. And what's 4 to the 6th and 2 to the 12th? I got the same value, so we're good. We get 4096 equals 4096, so we're okay. I'm going to keep x equals 7 and move on. Okay. Now, 36 and 216. They don't match. And I gotta see if there's a way to make them match. Well, best case scenario would be if 216 is some power of 36, right? So 36 squared, way too big. So what we're gonna do is we're gonna find a way to rewrite these as the same power of some number. or is the same number raised to some power. So if we think about 36, that's 6 squared. Can I write 216 as a power of 6? Well, try 6 to the 4th. Too big. 6 cubed. Hey, there's our 216. So I can change this one to 6 cubed. Bring down the 2x plus 4. Bring down the x plus 5. And we work just like we did before. 2 times 2x plus 4 equals 3 times x plus 5. 4x plus 8. 3x plus 15. Minus 3x. X plus 8 equals 15 minus 8. X equals 7. Okay, again, we want to check it. 36 to the 2 times 7 plus 4. Does that equal 216 to the 7 plus 5? Is 36 raised to 2 times 7 is 14 plus 4, 18, the same as 216 to the 12th. If we try to use our calculator for this, 36 to the 18th power. It's kind of a mess, okay? 216 to the 12th. It's a mess, but it's the same mess, so we're okay. Again, I could change that back to 6 to the 2 times 18, 6 to the 3 times 12. That's 36. That's 36. We're okay. I can bypass my calculator on that one. So we know we're good. Okay. Last example, and here we need to remember negative exponents. So first I'm just going to think about 64 and 16. What base can I use to make both of those numbers? Okay, 16 is 4 squared. Keep the 3x plus 1. 64 is 4 cubed, but it's a fraction, so it's negative. And solve. Negative 3 times x minus 2. 2 times 3x plus 1. Negative 3x plus 6. 6x plus 2. Add the 3x. 6 equals 9x plus 2. 9x equals 4. Divide by 9. And we get x equals 4/9. When we go to plug that back in, 1/64 to the 4/9 minus 2. 16 to the 3 times 4/9 plus 1. You have access to a calculator, so use it. Type exactly what you're looking at in there. So we're going to do 1/64 to the 4/9 minus 2. 16 raised to the 3 times 4/9 plus 1. Again, they're messy, but they're the same mess. They're identical, so we know we're correct. I'm going to keep x to the equals 4/9.